Since the first day of our existence, forces, energy, and matter have been ruling out over our lives. But over time, humans have discovered how these three things work and created laws and formulas to show us how these three things are related and how can we calculate them. Between all the physical laws, we have the laws of motion made by Isaac Newton, an English physicist and mathematician. There are three laws of motion, but here we're only gonna focus into the law of inertia. This one states that all objects will remain in their current state of motion unless an external force acts on them to change their motion. So, already knowing this, in this video we're gonna find about what is inertia, how is it related to the first law of motion, and how can we calculate it.
Well, I'm Vanessa and I'm gonna explain you a little bit what does the first law is. It is also called the inertia law, and obviously it was created by Isaac Newton. This law was published in 1687 when Isaac Newton published his book Mathematical Principles of Natural Philosophy. It contains the fundamentals of physics and astronomy, but too he formulated his famous three law. The law of inertia says that every body remains in its state of rest or uniform rectilinear motion unless other bodies act on it. This law establishes that a body doesn't modify its state of rest or movement if any force is applied to it or if the resultant of the forces applied is null. So we can deduce that all the bodies are opposed to changing their state of rest or movement, and this position is called inertia. 2. That the masses of the body understood and its quantity of matter is a quantitative measure of inertia of a body, and that a body is in equilibrium when the resultant of the forces acting on it is null. Like we know, the relative movement depends on which observer describes the movement. For example, in a train, for a passenger, the controller comes walking slowly down to the train aisle. But for a person who sees the train passes from the station, the controller is moving at a great speed. Therefore, a reference system is needed to refer the movement to. The law of inertia serves to define a special type of reference system known as inertial reference systems, which are those reference systems from which it is observed that a body on which another force acts moves with constant speed.
Hi everyone, I'm Gloria and I will talk about the inertia. Well, first we have to define what is inertia. The inertia is the property of a body by virtue of which it's opposed any agency that attempts to put in motion, or if it's moving, to change the magnitude or direction of its velocity. Inertia is a passive property and does not able a body to do anything except oppose such active agents as forces and torques. A moving body keeps moving not because of its inertia, but only because of the absence of a force to slow it down, change its course, or speed it up. There are two numerical measures of inertia. Its mass, which governs its resistance of the action of a force, and the moment of inertia about the specified axis, which measures its resistance to the action of a torque about the same axis. Well, saying that, we can say that the formula of the inertia is the sum of the product of mass of each particle, which the square of its distance from the axis to rotation. The formula of moment of inertia is expressed, or could be expressed like this way. So, as my partner Wendy said, inertia was best explained by Isaac Newton on his first Newton's law of his first motion's law. This law basically explained that the law of motion states that an object at rest is always at rest, or if it's in motion, continues in motion until external force acts on it. Let's talk about some examples. Well, a good example could be when the seatbelts tighten in a car when it stops quickly, or when a car is moving will continue even you switch the engine off. Or another example could be when we are pedaling a bicycle, and if you stop pedaling, then the bicycle continues until the friction of gravity slows down. That's all for me, and I hope you enjoy this video. And let's continue with my partners Samantha, Marlene, Kimberly, because they will show you more examples in a visual way. So thanks for watching. Bye.
Hi, I'm Marla, and I'm going to talk about some different examples of the Newton's first law in our daily life. The first example is the sudden brake of a car. When a car is going at a certain velocity and suddenly stops, it makes the passengers inside feel a slight push forward. When we are running at a certain velocity, it is too hard just to stop. If we can imagine or try it, it is going to be hard to do it. Usually we are going to need to keep decreasing the velocity until we can finally stop. Another example is when an object is resting on a surface and the surface is suddenly removed. The object will stay suspended in the air until the gravity acts.
Hello, my name is Samantha, and the following experiment is going to be related with the first law of Newton, which is basically that the motion of an object can be changed by its own because it needs an external force to be produced. So the materials that we need that can be easily found in our house. First, we need a glass of water, a plate, a tube of paper, and finally an egg. And also a towel if we don't want to wet the table. So starting with the procedure, this is optional, you can put the towel in the table. Then you're going to take the glass of water, put it in the center of the towel. Then the plate is going to be a bowl. Next, the tube of paper, you're gonna put it in the center. And finally, the egg. So in this way, what I'm going to do is to produce a force, and the egg needs to fall inside the glass of water. So 1, 2, 3.
The question is, why does this happen? As we remember, the Newton's first law of motion says that an object will stay at rest until something or someone apply an external force to the object. So, relating this to the video, we observe how the egg was keeping a state of rest until I apply a force with my arm. That caused that both plate and the tube to come out of rest, but these were sideways. At this point, the egg is still stationary for just a split second until gravity gets a hold of it and pulls it down into the glass.
In a summary, we can define the inertia as the resistance of an object to change their current state of motion. So, we can say that the more mass an object possesses, the more inertia it will have. In his first law, Newton states that any object will remain at rest or in a uniform motion in a straight line unless acted upon by an external force. Thanks to the real-life examples of inertia shown in this video, we can now identify situations where this law is being applied and create a relationship between the inertia and another physics concepts that we know.